Hello, physics class. In this video, we're going to talk about electric field lines, which is part of standard ES3. And it's a way of us visualizing the electric fields that occur around various charges. What electric field lines allow us to do is it's really a nice way to view spatially the space. Remember, electric fields identify the value of force per unit charge that occurs around some charged matter. And it's this point in space. So really what we're making is a map of the space around there, and the field lines will help us understand how the electric field varies through space. Electric field lines were introduced initially by Michael Faraday. When we do electric field lines, there's a couple things that we have to understand when we're drawing this one. First off, the electric field vector, and remember vector is a direction. So if you place a charge anywhere in an electric field, right, and you have electric field lines and you're looking at a location, the direction that the charge will feel a force on is always going to be tangent to the field lines at that point. The electric field vector and the force vector will always point in the same direction. When we're looking at an electric field line map, we can identify the value or the magnitude of the electric field by seeing how many lines per unit area there are in some sort of particular space. So the more dense the lines are, the stronger the electric field is. When you're drawing electric field lines, you have to make sure that you start at the positive charges and end at the negative charges. Right? So lines always go from positive to negative, and this follows our rule for electric fields that they're identified by how a positive charge would move. That would be away from positive, so starting from positive and towards negative. And when you're drawing these electric field lines, always make sure that you're starting the same amount at the positive and the negative charges, so they have to be equal amounts of field lines going to and from. And this last one is extremely important. Make sure that field lines do not cross each other. That is not good. In your notes, you'll see that there's various configurations. And I'm going to explain. This is the first one that you see in your notes, and you'll see that there's a positive charge represented here. For that positive charge, you can see the field lines coming off the positive charge. Remember that field lines are drawn how a positive charge would move. So for this positive charge, if you put a positive charge anywhere around this stationary positive charge, it would feel a force radially outwards. And the field lines represent that. They all have radial outwards. So the field lines just show how positive charges would move around the presence of a stationary positive charge. The next charge is a negative charge. And if you think about a negative charge, how it would respond, a positive charge placed around a negative charge, it would be drawn to it because opposites attract. The positive charge would be attracted to the negative charge. And here we see the field lines all pointing inwards radially towards the negative charge. Now the positive and negative charge are the most basic of our field lines. We get an interesting configuration when you think about a dipole. A dipole is a positive and negative charge next to each other. And the lines here show the path that the charges would take if you place them. So if you place the charge near the positive charge, a positive charge near the positive charge in this map, it would follow the path that you see here as it goes from the negative to positive, from the positive to the negative charge. It would be repelled by the positive charge. It would be attracted to the negative charge. And the force it would feel at each point is going to be tangent to it. If you looked at the monopole, so you have two positive charges here, you can see that in this situation, the field lines are all pushing outwards. This is how positive charges would respond if they were placed in this area. And that really just shows how we can look at electric field lines and how they would represent how positive charges would move in the space around other charged matter.